Welcome to Water Supply and Wastewater Engineering class. So today we'll be discussing lecture number 17, unit 7, that is the municipal wastewater collection and treatment philosophy. So if you recall, in the last unit, unit 6, we have started our new discussion, that is how to treat the wastewater for the municipal corporation. So here in the last unit, basically we have discussed about, we have find out what is the quantity of wastewater produced by the each city or the town, and how to convert industrial waste into the population equivalent, and all that we have seen in the last lecture in full details. So now in this lecture number 17, we'll be discussing about the laying out and the design of municipal waste. So let's get started. So before we start our today's lecture, let me give you the introduction, means why we are studying this lecture. So as our main philosophy was right to distribute the clean water, so what we have done at the beginning, right, from the river source, basically we have collected the clean water and we have treated it right in the water treatment. So through intake structure we collected and we treated it, and from the treated water we distribute clean water into the household, right. So once the clean water is distributed into the household, the consumer will basically produce the wastewater. Now the wastewater engineering will start from that point. So what will be the first job? So our first job will be to collect the wastewater, is not it? Then only we can design it. Then only we will purify it and ultimately dispose it into the river. So the first step is to basically to collect the water. So how we are collecting the wastewater? Basically we are collecting through the sewer pipes. Is not it? So that's why in this lecture number 17, we'll be discussing about the design of sewer, because we are collecting the wastewater and the waste pollutions through this sewer pipe itself. So we have to design the sewer pipe network, and through this entire pipe network we have to collect the wastewater, and then it will be treated for the further treatment, further process. So the hydraulic design of sewer pipe means the pipe layout, whatever we have done it for the water distribution also, if you recall, that we are using basically sometimes the gravity force for the transportation of water from one point to another point, because actually it reduces the energy consumption. Similarly, for collection of sewer, that sewer also, or the wastewater also, basically we have to design the pipe network such that the flow of water should pass from one point to another point by itself, or by the force of gravity. The flow, flow in the sewer pipe should happen. So the gravity design of sewer and the drains, because drain is also used for the collection of wastewater, right? Which means finding out the section. Basically, what we have to find out, we have to find it out the section of the pipe. Means what could be the dimension of the pipe, right? Whether it is circular dimension you are using, or it is a circle or a rectangular shape you are using. So depending on our requirements, basically we have to choose which type of dimensions, which type of cross sections we are using, right. And also what could be the gradient means one will be upside, right, because it means the top water will be flowing from top to bottom, is not it? So because of that gradient also we have to maintain it such that, so in general is generally carried out on the same line as the sewer pipe, right. So whatever we have distributed the sewer line, so the sewage line also, sorry, the water supply line, the swell line also will be in a similar form, in a similar location only. But always we have to maintain 3 to 4 meter distance between the water supply pipe and the swell pipe also. However, there are two major differences basically in characteristics of flow in the sewer and the water supply pipes. So what are these two things? So first one is basically, now we are collecting the wastewater, right? So before we have distributed the clean water. So in the clean water there was no solid particle, we have removed it. But here in the wastewater collection, basically wastewater will have solid particles present in it. So that is one major thing, which is the difference between these two things. And second one is actually the basically so basically what will happen is the solid particles will be settled down at the pipe itself, right. So that we have to take care, right. And what happens in the water supply pipe, basically sometimes water is flowing by gravity, but here sometimes if it is flowing by gravity, that is good, but sometimes you have to use pumps also for the transportation of water supply from one point to another point. So the problem with water supply wastewater pipes is that the wastewater contains the solid particle, is not it? And this solid particle has a tendency to settle down at the bottom of this pipe, then which will turn basically blockage of the pipe. So basically, if you see, this is a cross section of a pipe, and if it is a longitudinal cross section basically, and this is the flow of water is going, is not it? So the particles which are present, solid particles present in the water, present in the wastewater, will be settled down at the bottom, and after some time basically it will block the entire pipe, is not it? So that is another problem with this wastewater, because so that has to be taken care properly, so that this particle has should not settle down at the bottom, because if this happens then the entire system will get blocked, right? And also it should have a certain gradient also, so that the flow is happening by the gravity itself. So sewer pipe carries the sewage as a gravity conduit and therefore laid down at the continuous gradient in the downward direction up to the outfall point, right? It will be going towards downward direction from where so basically now we have to use the flow in a pipe system. There's those equations, similar equations what we have done it in the waste in the water supply distribution system also. So basically flow in the in the sewer pipe basically uses, we can use this three formula. First one is this Hazen-Williams formula. We have seen this equation in the earlier lectures also, where we have discussed the water supply network. So Hazen equation formula is one formula we can use. U is the discharge and 0.85 C constant, R is the radius of the pipe, and S is the slope. What is the slope of this pipe? And then or you can use the Manning's formula, or we can use the Darcy-Weisbach formula. So depending on our situation, depending on our utility, we can choose which type of formula we are using. So the design of sewer means basically we are finding out what is the dimension, what is the cross section of the sewer, is not it? So this depends. See, the flow of discharge is depends on the slope. How much slope is there, right? How much C is the constant area, and what is the radius of the pipe, is not it? So if you reduce the dimension of the pipe, what will happen? The flow velocity will increase. But if you increase the pipe dimension, the flow velocity will reduce. The flow velocity will reduce. So in that case, so we have to maintain the proper flow velocity, so that this particle which is present in the wastewater should not get deposited at the bottom. So that has to be taken care. The horizon, so using this formula, basically we are designing the entire sewer system. So next we have discussed one more term, we have to discuss, that is a minimum velocity. So in the water supply there is no term such as minimum velocity, right? But here the very important parameter is the minimum velocity you have to maintain inside the sewer pipe. Why minimum velocity you have to maintain? Now if you see, as I already discussed, so this is a pipe, closed pipe maybe you can consider, and this wastewater is flowing. So wastewater will have this type of solid particles, is not it? So if the flow velocity, if we are not maintaining the flow velocity, what will happen? If the velocity is very low, in that case this particle will settle down right at the bottom, and this will block the uh, pipe. So in that case basically the minimum velocity has to be ensured, that always the sewage water should follow the minimum velocity, so that this particle won't settle down at the bottom. This will simply move forward. So the flow velocity in the sewer should be such that the suspended particles, that is the suspended particles in a sewage, do not get silted up. That is, the velocity should be such that as to cause the automatic self-cleaning effect. Means this, if some particles are settled down also, if the velocity is a little bit high, then what will happen? This particle also will move forward and it will go to exit point, is not it? So that's why we have to maintain the self-cleaning velocity also. So that self-cleaning velocity means if any particle is settled down at the bottom, that also has to be removed through this. If you increase the velocity, right, then this particle also will be coming into suspension and it will go. So that's why in a day, at least one times, you should have a self-cleaning velocity in the fluid system. Then only this particle, if it is settled down at the bottom also, this should go out. Right. So that's what the generation of such minimum self-cleaning velocity in the sewer, at least once a day, is important, because if the certain deposition takes place and is not removed, then what will happen? Basically, this creates the obstacle. Right. Again, this will produce the problem. So this is, we discussed about the minimum velocity, you understand. So now as minimum velocity we have prescribed, now there is another term called maximum velocity, right? We have to make restrict our flow up to the maximum velocity also. Why? but they say again the problem is very similar. So in the clean water, when we distributed water supply part, that time there was no suspended solid present in the water, is not it? That's why we can send it in a very high speed. Whereas now the in wastewater, basically these suspended particles will be there. So this suspended particle will, whenever it is travels from one point to another point, it also interacts with the nearby bodies, the nearby pipe surfaces, right? Pipe surfaces also it will encounter, it will, there will be collision with the pipe surface, and because of this the wear and tear will takes place in the pipe surface also. That's why the velocity also you have to maintain. If the velocity is very high, what will happen? This particle, when it is traveling from left to right, it will impact to the wall of this pipe, and this will produce wear and tear in the pipe. So basically, like the lifespan of this pipe will again reduce. So that's why the maximum velocity also we have to restrict. So water also should not flow with a very high velocity, right? So that we call it actually squaring velocity. So that we call it squaring velocity, that also has to be maintained. So again, this depends on what type of material we are using as a piping material. If you are using steel, then maybe it will have some duration, but if you are using a concrete pipe, so in that case it will have different duration. So basically the squaring velocity depends on the which material we have used for the construction of these wire pipes. Okay, so that's why always we have to maintain the minimum velocity as well as the maximum velocity also in the sware pipe system. And lastly, we'll be discussing about the effect of flow variation, right, in the sware pipe. So as we have seen that during the water supply phase also, that we are the water supply demand is not uniform across the day. So in morning time maybe water demand is more, even in the evening time water demand may be more, but in the middle intermediate afternoon time, or maybe at the evening night time, the water demand is very less. So that also impacts the wastewater distribution system, also water wastewater collection system also. So the due to variation in the discharge, the depth of flow also varies, is not it? So if you have a pipe, so maybe this is the pipe system. So the at the morning time maybe the entire depth is very high, means the water is more, wastewater is coming, so this may be the entire depth, is not it? But during maybe night time, what happens, the flow is now reduced, so the flow level may be something like that, 50%, right? If you see the cross section, at the morning time it was completely filled, right? Whereas in the evening time or maybe at the night time, the flow section is maybe something half like that. So this also varies, right? So the hydraulic radius, so this we call it hydraulic radius, also will get reduced. So this again hampers the minimum velocity, right? A minimum velocity also. So we have to design the pipe system, means we have to find it out the dimension, what is the radius of this pipe, and what is the slope of this pipe. All these things has to be adjusted so that the wastewater velocity should maintain the minimum self-cleaning velocity at least once in a day, and also it should be less than the maximum flow of water. Okay, so basically these are the parameters which we have to keep it in mind, and while before designing the sware pipe system. So this concludes basically this lecture. So in this lecture, what we have understood is the wastewater, how we can design the wastewater sware system, because through these sware pipes only we are collecting the wastewater, and which will be sending into for the further treatment process, is not it? So we have seen two important things here. One is the minimum velocity. Minimum velocity is required to clean the particles which is settled at the bottom, and also so the other suspended particles should not deposit at the bottom. So there should not be any sedimentation happening inside the pipe. And second one is the maximum flow velocity. If the velocity is very high in the wastewater pipe, then again it will produce wear and tear in the material, sware material, sware pipe material. So again this will again reduce the lifespan of the entire structure. So that we have discussed in details in this lecture. Thank you.